Okay. So what we're doing today is we are going to take a look at slopes to start and a little bit with inequalities to finish up at the end with some things. So here's kind of our doings. We're still going to use the slope formula that I've written up here at the top. Now it's not on yours. Focus in, please. Yeah, I don't mind that. So here's kind of what I'm trying to do. I'm going to do like I have before. If I look at these first two parts of my box, the first box represents my x's. The second box represents my y's. So when I'm working on trying to find the slope or the rate of change, which is the fancy word for it, all I'm basically doing is I'm looking at these like they're coordinate points, just like we were doing before. Yeah, because what I would do is I would take those coordinates and I'd plug them into the formula. Now we talked before, the order you do them doesn't matter as long as you're consistent with it. So like with my y's, I could do 4 minus 2 or 2 minus 4. And again, some of you will go one way, some of you go the other. So some of you went 2 minus 4, we'll see if we get the same thing at the end. When I go to do my x's, right, do them in the same order. So if I started with the 4 for the y's, I got to start with 2. And I get my answer. And I like the fact that it's a fraction because it's going to help me with my rate of change. Okay? This is constant because no matter what 2 points I use, I get the same answer. Okay? We did have to reduce. Yep, that's absolutely true. I could just do like 6 divided by 3 and I'd get 2 over 1 as well. That's very true. That's a good thought. So my rate of change here would be 2 over 1. But what that means is, it's true, but it also in this case means for every 2 games that I play, I get 1 goal. We're looking at it as far as the rate, not if I were to graph it, what am I doing? But that's why we're labeling as we go. Now, wait a minute. They're sitting here going, Hardy, wait a minute. Anybody have anything they want to mention here? Well, no. Something even worse than the fact that it would be bad odds. What did I do incorrectly here? Feel like you did something wrong? What letter's on the top of my fraction when I'm doing slope? Y. Y. Is games Y? Uh-oh. 2 goals, because goals is my Y and Y is on top. For every 1 game. Oh, that's much better. I have to be careful, though, because that's very easy to have happen unless I'm labeling things in my chart. So when I'm doing those, make sure that you label properly, because I almost even messed that up myself. All right, one more of these, just to prove a point. I can use any 2 of the points that I want to with this. So let's say I decide I'm going to use the middle 2. So again, my point will be 384. Wow, we're getting some big ones now. And 140. And again, I want to label my gallons and my miles. So when I get to the rate of change, I don't mess this up. So when I go to do it, yep, my y's go first. And again, whether I do 140 minus 84 or I do it the other way around, as long as whichever y I start with, that's the x I start with. That's true. So my rate of change, 140 minus 84, like Mike said, is 56. 5 minus 3 is 2. But I always want to reduce my fraction down, whether that's doing it, with mental math or whether it's even using math enter on the calculator. But I want it to stay a fraction no matter what. So it is consistent, it is constant. And what I'm going to do here is, again, take my fraction. Yes, because remember, it's the y's on top, and my y is miles. So 28 miles per gallon. Right, because I'm putting, my mistake I'm making is I keep putting the 1 in the chart. If I didn't put the 1 in the chart, this wouldn't be so obvious. But that's a very good thing you're mentioning. Because Chris just said, well, if you look at the first chart even, 2 goals per 1 game. Look down here. 28 miles per 1 gallon. Well, then wait a minute. Yeah, it looks like it's going to be. I know, I like the way you think. Now see, that is a very good way of using a little logic and common sense to get where you want to be. Well, unfortunately here for you guys, Chris happened to mention that and see that. That's very well thought of. Now, if you didn't have that, you know how, but since you catch that, that's good. That's even like a good test-taking strategy if you start to notice a pattern. Okay. Here we're just looking for slope. Now, I want to add one thing to this. I want to figure out what type of slope it is, where it's positive or negative. Okay, now, hang on. How do you know it's positive? Okay, since it goes up as we're going from left to right, I know it's positive right away. So if my answer comes up anything but positive, I know I'm going to have an issue. Now here's the one thing you do have to watch, though. Notice there aren't dots on the line this time, like there have been before. We still have to pick them out. Now you can pick, any of you that are hunters or do video games with hunting and stuff, sometimes you have like, well, we'll see. We've got, yep, because no matter where you look, you're looking for the crosshairs. If you find someplace where the crosshairs are, you're going to find consistent points that will work for this. Now, Allie already mentioned what the actual answer is going to be, because again, remember, yep, you got it, okay? It's just rise over run. How much am I going up or down over how much am I going right or left? And we mentioned before, you go up it's positive, down it's negative. Sorry. That's okay. And then right is positive and left is negative. So when I'm going, and I can pick any 2 points I want on the line. So let's say I pick those 2. I went up 2, which is positive. I went right 1, which is positive. And that's my slope. That's it. So as you go through these, your first job is always going to be to find those crosshairs that our grid makes and make your points, because then it's going to be easy to count how much it's up and over to get from one to the next one. Now there's one more of these I want to take a peek at, and it's not that one. Here we go. This one, it may be hard to kind of see where the line's at. Okay, we're in the slope packet. We're in the middle of it. Huh? Yes, the thick black line. So, yes it is. Because we remember from the slope guy that his mouth has the little zeros, little dimples on the side. So whenever we see a flat line, slope is just 0. Okay? And that's it. Right. It should be, because that's Mr. Slope Guy's nose. If we have Mr. Slope Guy's nose, right, that has the U underneath, that's going to be undefined. It's on the back of the packet. And then for the last part, all we're going to do is we're going to use the slope formula. No, because the slope itself isn't a no solution. It's actually undefined. It's a slight difference. And then the last part's just like what we've been doing forever. You take your points, minus is in there, and again, it doesn't matter. You want to, yep, y always goes on top, and whichever y I start with, I need to start with the same x. Nope. Minus 6 is negative 2. And since that doesn't reduce evenly, 2 doesn't evenly go into 3, I'm done. Okay? Don't go to a decimal. Okay? Don't go to negative 1.5. If it doesn't reduce evenly, then just leave it alone. So again, we're trying to keep life simple today. And then the only other thing we've got on our to-do list, I'll get this to you in just a sec, is this practice 5.4b, remembering this and and or stuff. So there's a couple on here I want to do with you too. I want to do an and, I want to do an or. No. So for 14 and 17, those are the two we're going to look at. If there's two separate ones, we're going to go ahead and we're going to solve each one. So how do I get the y by itself in number 14? Add 5. And then I do the same thing for the other one. So if they're split, we do it separately for each. So then all I got to remember is, okay, oh boy. Y is less than 1. Two questions. Is my circle going to be open or closed? Okay. Open, because it's just less than. It's not or equal to. And if y is less than, when the arrow is pointing at y, it's going to go to the left. Then I do the same thing over on the other one. Okay, closed circle because it's or equal to, and since y is greater than, since the arrow is eating up the y, it goes to the right. And that's typically going to happen on your or statements. They're going to go out from each other. Sure. If the y is on the left side, you can. Basically, that would be true. That's a good statement. What was just mentioned was, in case it didn't end up on my microphone here, if your y is on the left side, can I just follow the arrow when I'm drawing it? Absolutely. But if your y ends up on the other side, it ends up on the right sometime, that's when you'd have to think of it the opposite way. So, but that's a very good thought process. Absolutely. And then 17, now it's a little different. I have a compound inequality. It's got 3 parts. I still am trying to get b alone in the middle. What's my one step to get b alone? Add 4. Okay, so add 4 everywhere. Because now the b will be alone in the middle. 2 plus 4 is 6. Negative 6 plus 4 is negative 2. And any time you get a 3-part inequality, the only thing you really have to think about is if the circles are open or closed. So what are these going to be? Okay, these are both going to be open. Open at 6, open at -2. And whenever you get the compound, you just color in the middle. You're just coloring from dot to dot. Because b is less than 6, which would be to the left, but b is greater than -2, which would be to the right. That's why they color into the middle. Again, the sheets that I've pinned up to the front, if you need an extra one of those are still over in the folder area. Okay? Or if you see them and they're not in your folder, or you want to see if you turned them in or not, I can help you out with that too. But then I was going to give you some time to finish those up and do this, because tomorrow I have an activity planned. I have an activity. Yes. Yes. In a game type mode. Most of it does not.